and I will show you a brief presentation about Heilind, who we are and what we do, and then I will pass to Stanislav. So in general, Heilind Electronics is a global distributor of electromechanics and fasteners. We were founded in 1974 in United States. We have more than 1,000 employees all around the world, and we cooperate with more than 120 suppliers globally. We work with the customers from few and from different market sectors. So we cooperate with the customers from Miller Aerospace divisions. We cooperate with industrial customers, EMS, and so on. And of course, metal sheet fabricators and customers working and supplying the sector from transportation, so railway, buses, and all around the transportation. Also, we are visible in automation and controls, home appliances, and so on. So we try to cover a wide range of the market sectors and of the customers. So we have in our portfolio, of course, fasteners. PEM is our biggest brand and biggest partner in the fasteners industry. But our core business is electromechanics, and we are also doing connectors, relays, wires, sensors, and everything that is connected to electromechanics. But of course, today we're gonna focus on the fastener portfolio. So just for you to know, our warehouse and our structures are in Germany, because when we entered Europe, we firstly acquired small local distributor in Germany in 2015, and then we expanded into 2019 for Central Eastern Europe countries. We have office in Krakow, which is covering Central Eastern countries, so Poland, Czech Republic, Slovakia, Hungary, Romania, and Baltics. So this is our scope of the business. Moving forward, here is our global footprint. So you can see that we are a global player. So also if your customers are there, we can also connect with them, I would say, whatever they are, US, Europe, or Asia. In Europe, we are still quite fresh, but we are growing really fast, and we have, I would say, big ambitions to become stronger and grow faster than others. Here you can see closer. So our warehouse is a orange dot. Our warehouse is located in Germany, near Munich. And this is our main distribution hub covering Europe. So also all PEM fasteners that you would purchase from Heilind would be sent from this warehouse. Just for you to know, as probably some of you have already problems with Brexit, PEM is manufacturing their fasteners in Europe. It's their main factory is in Ireland. So Ireland is, of course, a part of European Union. So this is very important for you, that we have no delays in the productions. This is, let's say, we have almost no impact because of Brexit. So during next months, we will try to use this advantage against our competitors, and we have strong supply chain behind. So reasons why to choose cooperating with Heilind: we try to be close to our customers. We speak in local languages. We are both regional and global. We have our field sales engineers close to our customers, visiting them and traveling. And if you need anything, you can contact them. Also, we have our product team, which I'm a part of, so we can help you in your technical aspects of the application. Together with PEM, we are always investigating separately every application. We are also trying to be close to your projects and design-ins. So this is very important to us to work with our customers from the beginning, where there is a possibility to solve your problem through our products. This is something that makes us happy, and yeah, we are trying to be close to you here. Of course, we are also supporting prototyping. So if you need any samples for the application, normally samples are free of charge. So let us know, and yeah, we are shipping small quantities to our customers. So I would say that's a brief introduction of Heilind, who we are and what we do. So now I would like to pass to Stanislav, so he can start with our webinar and with PEM products, applications, and PEM portfolio. Thank you. Stan?
Okay, hello everybody. Thank you, Dominic. Thank you very much for nice introduction, and also thank you for organizing such a nice event. Really welcome all to our webinar and presentation. I will go through various. Do you see my screen, guys? Just to start with.
Yes, yes, but you can make it for the full screen.
Yeah, we'll do. I just, yeah, excellent. Great. So again, welcome all, and thank you, Dominic, and our partners in Heilind for organizing such an event. It's great to have you all here. As Dominic mentioned, my name is Stanislav Hresko, or Stan for short, for easy pronunciation. I'm regional sales manager for Central and Eastern Europe and Ireland. And on the call, we have also Rafał Cybulski, who is a sales manager for Poland and also supporting Romania and Hungary and Baltic countries as well. What we are going through today, guys, is the company overview, just a brief introduction of the PEM engineering and services that we offer. We'll go very briefly through the self-clinch theory, how it works, what to do and what not to do in terms of the self-clinching installation. We will go through the common performance test, how we are testing the installation of our fasteners, and few examples of the application where you can use our fasteners. Before I will start, please feel free to stop me at any time, or if I go too fast or too slow, let me know, or raise your hands. We have a section at the end for the questions, but if there is anything in particular that you would like to address straight away, please let me know, and we will try to answer your questions throughout this course. So, PEM Engineering Company, to give you the company overview, is based, and it was founded 76 years ago in a small town called Danborough in Pennsylvania, which is the small town near Philadelphia. And our main headquarters is still there, up to date. Our company was founded by Mr. Swanström, who was a Swedish immigrant, and he invented self-clinch nut in his garage. And since then, our company grew significantly to the current global presence, as you can see on the slide. In the North America, we have several locations where we manufacture and stock our items. So in Denver, as I mentioned, is the headquarters where we have the manufacturing location for our cold forge products. In Tom Rivers in New Jersey, we have our Hresko headquarters, which is our company that supplies the plastic components. Then in Waterford and Vaughan in Michigan, we have our automotive industry support for the North American market. In Winston-Salem, we have a manufacturing location for screw machined items. And in Oakdale in California, we have our Hager headquarters, where all our Hager installation equipment are manufactured. Plus the tooling and engineering side is there as well. I will go to Asia and we will end up in Europe. In Asia, our Asian manufacturing location is in Kunshan. We have also offices in Shanghai. Recently, we acquired distributor in Japan as well to increase our footprint in Asia, and also we have an office in Singapore. And last but not least, in the Europe, which is our main topic for this webinar is headquarters in Galway in Ireland, which is the small town in the west of Ireland. And then we have office in the Oldenzal for the Hager installation equipment, plus 2 manufacturing locations in Fulda and Friedrichsdorf, sorry for my German, which are our profile manufacturing location. Our thinking or logic behind it is that each location has its own manufacturing location or manufacturing facility. So in Denver and Winston-Salem for North America, and Galway for Europe, and in Kunshan for Asia. So we are able, as Dominic already mentioned, to react quite quickly to customer demands in each of the regions. And it really gives us benefit over our competitors to have manufacturing location here in Europe and to be more flexible for our European customers and to address their needs and requests. As there are a few facts about our company, as I already mentioned, 76 years of history. We have over 3,000 employees currently employed by PEM Engineering globally. 10% of our employees are engineers. This really speaks volume for us where our focus lies. Even our name gives a hint that our main focus is on the engineering. We are not a simple commodity supplier, and we don't want to be seen as a commodity supplier because a lot of our expertise is in the engineering. We would not pretend that we are experts in what customers are manufacturing, but we are experts in our products, which is the self-clinching fasteners and joints for the sheet metal and for the other types of the connections. We have 19 locations across the globe with 8 business units and 7 development centers. Development centers, again, are connected with our engineering capabilities, where we are constantly developing our products to make sure that we are ahead of the competition and that we are keeping touch with current demand on the market, at current trends, because it's constantly developing. Our current product portfolio and our sales channels for the PEM, which is our core business, our self-clinching fasteners, we are working through authorized distributors as company Heilind, and also through direct sales engineers, but this is more related to other activities and other markets. Then our Hager installation equipment portfolio, we are working through authorized distributors as well. Again, direct regional sales and service managers, plus we have a team of service technicians on the field that are supporting service. MicroPEM is our relatively new brand. It's a product that is primarily for consumer electronics and for the small equipment that we are using every day, really, which are tablets, laptops, mobile phones. Everything smaller than M2 thread size would fall under this category. We as a PEM took a step a few years ago and identified this as a growing market, and we dedicated separate product line for this type of the products. And this has been one of the most successful product lines that we've introduced, or brands that we have out on the market, is really to address these needs for consumer electronics companies. There are big players, and we are working closely with them to address their needs and demand for the self-clinching fasteners and other inserts and materials that they are using in their product. Another brand is a Profil, or PEM and PEM Auto. Those two brands are primarily targeting customers in the automotive sector. Profil, our sister company, has a very strong footprint in all of the big OEMs in terms of the automotive industry. And PEM Auto is our facility in Asia, in Kunshan, where we are making specialized products for automotive industries. These are really separate sections because of the machinery that they are using, and the equipment to manufacture them would not necessarily fall in line with the PEM self-clinching standard core products. Then we have Atlas product, which is our rivet, blind rivet through true threaded rivet solutions for our customers. And last but not least is the company or brand Hresko, which supplies plastic components, various plastic components. Their range is massive for electronic industry, but it's not limited only for those. So PEM engineering really is an umbrella covering all those brands and companies that we operate and supply to our customers. So based on this, you can see that we can support customers not only by supplying self-clinch fasteners, but it's a very wide range of the solutions that we can offer to the customer. Here are listed several benefits of partnering with PEM engineering, and there are listed technical innovation, marketing, leading brands. You can read them through. The message here is really that we are a company that is very stable, very strong, with a strong focus on the customer. We are working and cooperating with the leading brands on the market. We are constantly trying and we are developing new products. We are improving ourselves. We are looking on the ways how to improve total installation costs for our customer. We are working closely with those customers and identifying solutions for them where we can reduce the cost by using replace components or use better solution. With the self-clinch fasteners, and you will see it in the next slides, our fastener footprint is smaller compared to competing technologies. So we are also reducing the footprint in customer application, which is very important, particularly in these days where everything is going, or the trend is that the panel thickness is thinner. We have a less space where to install the fasteners. So our fasteners are really ideal solution for this type of the challenges. Also, we have a very high focus on the environmental issues, where we have a dedicated sections on our website where we are complying, and you can see our certification on various standards and requirements that are out there on the market, starting with ROHS, REACH, any other environmentally related and other related issues. We have those, and if you won't find them, please let us know through our either Heilind distribution partner or through a file if you are looking for something in particular. As you could see on the map, we have global manufacturing footprint, which allows us to react quickly for the particular demand on each of the regions where we are present. We are a full system supplier, means that we are not supplying only fastener, but we can supply with a full solution, starting with the review of your application, how you are installing or how our customers installing fasteners, and continuing on through evaluation, cost revision, where we can review and advise how or what is the best way to install our fasteners and how to process them. Clean fastening solution to VDA 19 standards. We are working with the safety critical solutions, which have very high standards in terms of the quality and documentation required for it. And also our fasteners are tamper proof. What does it mean is that the fasteners, once it's installed correctly, is becoming the integral part of the panel or the chassis where fastener is installed into. By this, fastener is becoming part of the chassis, and hence he cannot fall off, and does not allow anybody else to tamper with it without significant mark or destruction of the panel, which is the sign that somebody has tampered with a given application. In terms of the markets, we are supplying anywhere where threaded joint is needed or where some sort of a spacer for the thin sheet application are needed. If you look pretty much in any application, in any equipment, I believe you would find some of our fasteners that are present there. I'm just listing here a few, but we have very strong footprint in automotive industry, and this is going throughout the entire car, really, from the chassis. Then we have automotive electronics, which is a very strongly increasing market segment at the moment, where pretty much everything in the current car is going towards this direction. We have a lot of electronics nowadays in the cars. We have a lot of touch screens, and we like that. We like this kind of gadgets. I think every single one of us. And basically, for all these new applications, we are supplying to those as well, and we are seeing, as I said, tremendous increase in this type of the market segment. As I already mentioned, consumer electronics, the primary brand that we supply to is micro PEM, but it's not necessarily only micro PEM, because some of the laptops with a bigger footprint allows us to use other type of the fasteners. Datacom, again, very strongly increasing market at the moment due to the increased demand in telecoms and datacom services, purely because due to the current situation in the world, a lot of meetings, as we have at the moment, for example, has moved to the online world, and this increased the demand in the switch, server, and routers applications, datacom, big towers, and so on. So really, this covers everything there, and again, very strongly increasing market segment. Another one is electronic vehicles and charging station. Again, due to the initiatives of governments across the Europe, it's led by Europe, but now North America is catching up as well, and Asia. We are seeing increase in this market segment where we are trying, I believe, within PEM engineering, we caught up very quickly on that, identify this potential, and we have a dedicated team related to automotive electronics and electric vehicles. Our team strongly focuses on those market segments. And again, we have very heavy and strong presence in those markets. And then traditional industrial, this will never go away. We will still have a lot of work there. Where good old industrial market segment is always present, and we always will have a need for chassis, for bending, for metal enclosures, and of this type of the materials we are supplying to those as well. And last but not least, that I listed here is the solar and alternative energy applications, where we are supplying to any other solutions for this type of the market. These markets are really just a flavor. There are many more where we are supplying to. Medical, due to the unfortunate situation, we've seen strong demand there as well, and we were able to support this demand throughout our European facilities and other facilities across the world, white goods and so on. So it's not only limited to those markets. These are really just to give you a flavor where we can supply. Service, in terms of what PEM can offer, is it's branded under PEM Edge service, and this includes teardown testing and application engineering support. Teardown services, what we are doing there, we have two separate approaches there. Is we will completely disassemble product. Then we will look into the potential solutions where we can replace current, either joint, loose screws, any other components that we identify as the solution to save the cost. It's not necessarily to push our products in, which would be ideal, but it's really just to save the cost for the customer. Then we will, everything is done throughout this process is documented. We have the entire report. We do publish those, and this is where we have two approaches. One, we buy known product on the market and we publish it on our website. If you are interested, maybe you can reach out to Dominic, Rafael, or myself for the information where to find them. And you can find the solutions what we are proposing for those. The second approach is we work directly with the customer, where he's working on the project that requires NDA or non-disclosure agreement to be signed. And in this case, nothing is published outside PEM engineering. Everything stays here. We submit the report only to the customer. And if there is any need to scrap the workpieces or send back workpieces, we do that as well. So this is where we have two different approaches depending on the sensitivity of the projects that we are working on. So overall, we identified the solutions to the customer, we presented to them, and based on their feedback, again, this service is free of charge. We do not charge that for any type of the service, and then we will present the report to our customers. If they will decide to go the route that we are suggesting to replace the fasteners, we are helping our customers to work on that as well. And we will put together an implementation plan, what is the best way to apply our products into the given application. Then we are offering testing service, and it varies depending on customer application. So we are doing finite element analysis. This is helping us to theoretically analyze the project, what's going on, what's happening with the fasteners, installing into certain type of the material. And this is really just to give customer confidence that we know what we are doing, and to give us theoretical overview of what's happening inside the material, to help us understand how material and fastener behaves during installation and during self-clinching operation. This is followed by the mechanical testing, because it's nice to have the theoretical calculation, but it needs to be proved in the real life. And we all know that there might be some discrepancies, there are deviations in the material specification, thicknesses, tolerances, everything considered. We still need to have the physical proof that the testing is or the specification is applicable and meets requirements. So we do mechanical testing, tensile and compression testing. We do micro hardness, which is to ensure that our products are hard enough, and later on you understand why. Fastener joints cross-sectioning to help us see what happened in the real life, and corrosion and plating testing. All these testing services can be done in each of the locations. So our Galway facility has capability to do every single one of those tests for our customers. And again, this type of the testing is free of charge. And last but not least, PEM Edge service is application engineering. What we are doing is, for our special applications, we have dedicated application team who are working on the review of the given application. They will come up with a custom design and develop the product. We supply the customer drawing, provide the samples, if required 3D models. With the 3D models, note that they won't be fully known or we will not show all the features of our products, purely because there are some confidential and proprietary information there, which is our know-how, how the self-clinch works. But in terms of the physical samples and in terms of the footprint in the customer design, it will be sufficient. And then we have a prototype developmental center. So as you can see, PEM Edge covers wide range of the services that we can offer to the customers, and all of them are free of charge. So we encourage our customers to give us applications, to challenge us, to present us with opportunities where we can provide solutions for them. And in case of the customers, really, we work either through distributors in Heilind. So if you have any questions or any issues, please do not hesitate to, again, contact Dominic or Rafał or any other representatives, VRL in this case as well. So why to choose self-clinch? I've touched that previously. So because it's a tamper-proof, but I will start from the top. So strength, we are offering our products. 90% of our products are heat-treated products. So we are offering a very strong thread. If we are comparing it, for example, with the weld technology or tapping technology, our threads are stronger due to the hardness of our fasteners. In process installation, parts are installed into a plain round hole. There is no secondary operation required. So you don't, once our fastener is installed, and you can see it on the animation here. Once our fastener is installed, you don't need to do any additional operation, cleaning, deburring, removing any additional components if you are comparing to welding. It's very clean and very nice process, excuse me. And we are also reducing the cost in terms of the installation cycle times. Our machines, secondary installation equipment and in the installation equipment, are pretty fast in terms of the installation. You don't have any additional processes. You can automate the process, and this will significantly reduce the cost of our overall install cost. We have a design flexibility, so we can, and we are installing our fasteners into the metals that are dissimilar. Again, advantage over the competing technology of welding. And as I already mentioned, it's a very clean process. You have no additional elements going into the process. There is no weld splatter, less energy is required, purely what you need. The idea of self-clinch itself is very simple. You just apply the force and install it into the panel, and material will cold flow, as you can see on the animation. So all that we require of work, all work is done by material itself. What you can see here on the blue in the animation. I will start over and yeah. So installation process itself, very simple. You place the fastener and then you can, and then you can install it by applying the force. Self-clinching, I will just go very briefly. We are not going to spend too much time on the technical description of it. It's just to give you an idea and an explanation how it works. So we have two main features of the self-clinching or self-clinch fasteners. One is displacer and one is undercut. Here we have two scenarios. One is before installation and the second one is after installation. So you can see here a fastener is placed on the prepared material with the mounting all to the prepared to the right size. This portion of the fastener is the displacer. Displacer is the portion of the fastener that displays material. Its name have a giveaway, so by applying the force, displacer will move material into the desired area. It's these are the features that we do not show on the 3D models, and we do not share information about its dimension and shapes and so on, purely because it's our know-how and we know the proper volume ratios between those features of the fasteners. So displacer is displacing material by once we are applying the force, material will flow into the desired area, and desired area is the undercut, which will receive the displaced amount of material. So here on this side, we can see that material has moved into the undercut, and this is what retaining material into the chassis. Here you can see on this type of the fastener, which is our S-nut, we have what we call knurled or serrated ring, which provides the resistance against the torque, but we will go through it in the next slide. So this is the design intent of the installation of the S-nut. What we have here is how typical joint is designed for and how it works using the self-clinch fastener. As I already mentioned, we have a displacer and we have an undercut where host material did flow into the undercut after installation. This is the direction of the installation force. In PEM language, this is what we call head of the fastener. Head is the portion above the panel where fastener is installed. And this portion is our displacer or serrated clinch ring that provides torque resistance. And tapered shank is the portion of the fastener. Here is the component or material, mating material, and the mating screw once it's tightened. That's joint in tension, and we have desired design intent of the fastener. Advantage installing S-nuts is that it's flush from the other side of the panel. So basically you can have very nice surface-to-surface contact with the mating material. Again, I don't want to go too technical here, but are there any questions in relation to that? Is everyone okay? If there will be silence, I'll take it as a yes and we can move forward. Okay. Here is another big product group, which is our stud. Stud is our externally threaded fastener. And principle is very same on every type of the fasteners that we do. Self-clinch principle is the same. It just shape and the type of the fastener changes depending on whether we are looking at the internally threaded fastener, externally threaded fasteners, and whether it's a spacer or any other type of the fastener. So again, this is the design intent of the stud. As you can see, the shapes are different, but the principle is the same. So we apply the force from this side or other way around, depends how way you are installing it. In this case, displacers, we have two displacers, which is the head of the fastener and the locks. And these displacers are moving material into the two undercut areas. One is secondary and one is primary. And again, this portion is holding and retaining fastener in the metal or in the sheet. Ribs or locks, they do provide torque resistance once fastener is installed. So if you are trying to twist the nut, this is what is retaining it and preventing fastener from moving into the in the panel. And again, we have a mating components, a mating panel and mating component, which is nut. And once we will have everything joined together, we have the threaded joint. And the last big group that we have is the standoff, and also the design intent of the standoff. So standoff is probably the simplest one of all our groups. You won't see it from this slide. Unfortunately, I should have prepared better, but this is a hex head. Standoffs, they do have a hex head. And this hex head shape of the head is the design that preventing it against the torsional, against the torque. And this acts as a displacer and moving material into the undercut. So it's in very simple terms. It's probably the easiest one to explain onto, where we are applying the force. Displacer is moving material into the undercut, and that retains the fastener in the panel. And standoffs are really as a spacers between two different plates or planes. And by the distance, we mean the body of the fastener, and it can be supplied in different lengths depending on the required distance between the panel. And we will tighten it with the mating screw. So on those three, I think these are the best explanation of the self-clinch theory and how it works, and gives you an idea how self-clinch and how fasteners are retained in the panel. The reason why we picked those three is to show you the variance in the displacer design and in the undercut design, but principle is very same for all three of them. So you can have the variation of the displacer, of the design, of the shapes and the sizes, but principle remains the same, and fastener is retained securely in the panel. Some major do and don'ts, or some advices what you should be doing and what we shouldn't be doing to successfully install the fastener or to make sure that the connection is correct. General rule is panel has to be softer than the fastener. In general, rule of thumb is 20 points on the HRB scale. Fastener is harder than the panel. The reason for it is, and you will see it on the next slides, the reason for it is fastener has to facilitate the movement of the panel. So it has to be harder, it has to be tougher than the panel to make sure that it won't collapse or will be destroyed or damaged during the installation process. We need to have adequate sheet thicknesses. This means that we cannot install fasteners, successfully installed fasteners below certain minimum value that we do specify. We provide information about all parameters that are required to successfully install fasteners in our literature. If you have issues to find them, please do not hesitate to contact us or our distribution partners. We will provide this information because we want to make sure that the fasteners are installed correctly. So we need to have certain minimum sheet thickness, and it's purely has to do with the volume of the material that we need to move. Then pre-punched holes. Hole preparation is very important. We need to have a clear access from both sides. It means that we need to apply force from one side of the fastener and have a support from the other. It's again down to the how self-clinch works and how panel flows. If we have access only from one type of the front side of the panel, then we would be looking at the Atlas style rivet products. And insertion press must have adequate throw depth. It means that we need to be able to place the workpiece in the press, or we need to make sure that the workpiece fits into the, in other words, fits into the press. We will go through each of those steps separately. So sheet material must be softer than the fastener. That's what we already said. So if the fastener is not hard enough, it will crush or deform itself, and cold flowing of the material will not occur, or it will occur in the limited way. What will happen then is that the fastener will not move enough material, fastener will not be retained correctly, and worst case scenario is that it can fall off of the sheet, and that's unsuccessful or an incorrect installation. In this case, really, we would encourage you, if you have any issues like that, talk to us, let us know what the issues you are seeing, and we might be able to help you. It can be as simple as the using different heat treat specification for our fasteners. Also, I would like to highlight that some operation will locally harden a sheet. For example, punching 300 stainless steel or laser cutting a mounting hole. What will happen, what we are meaning by this? If you have application for using stainless steel panel, 300 series stainless steel panel, if you punch the hole, material itself is trying to protect itself, and it will harden around the area where we are punching the hole. This phenomenon is called local hardening. So if you have, let's say, panel hardened or specification at 90 HRB, the area around the hole where you punch it or deform it or did some sort of operation will be harder, and it can go up to 100 HRB. Depends. It's I don't want to give figure because it depends on the material and its components that is made from, and also elements that are made from. And laser cutting as well will local harden. If you work with laser cutting, you know that the area around the hole is not aesthetically pleasing, and there is a certain portion of material, and this will harden the material around the hole as well. These are some examples of installation, how it looks when the panel is too hard. So as you can see, knurl here it should be nice and straight, but as you can see, it's already collapsed and it's rounded. Undercut is not fully filled. You can see the missing portion of the material in this area. And this is a very bad example where you can see the clinch completely collapsing. We didn't move pretty much any material except this tiny portion here, but that's useless. As you can see, the fastener is completely deformed. Thread shape, I'd say, is gone. We cannot use this type of the joint as well. You can see fastener bulged or swell here and here. So we were closing the threads, we were changing the specification of the thread. So these are some of the issues that you can experience when not installing with the proper hardness or into the too hard panel. So we need to have a good match between the fastener hardness and the panel hardness. So all these can result in the bad installation, bad joints, and at the end of the day, customer that is not satisfied and not happy. Here are a few examples how it can look. So you can see fastener before installation, where you have very nicely defined knurl, and after installation when it's completely crashed or collapsed. And similar for the studs, where we have nice pronounced locks, and here they're almost completely flattened. So if you have any issues, or if you come across any issues like that, please let us know, and we are happy to investigate anything for it. Or we advise to use customer correct panel hardness or fastener specification. To let you know, we do control our manufacturing processes very tightly. Each of our batch has its own hardness record, so we can review if in any particular case there was any potential issue with the hardness on our side. So do not hesitate to let us know. Sheet thickness is another critical factor for successful installation. As I mentioned, most of our standard fasteners have the minimum sheet thickness requirements. This is really to ensure that fastener has enough volume to move, to make sure that the installation is correct and the fastener is retained in the panel correctly. What could happen is that if we don't have enough material, undercut is not within a sheet, so undercut will be outside the sheet, meaning that it can't receive anything, any material. And if shank is longer, potentially can protrude from the other side of the panel. So we will lose advantage of having nice face-to-face contact with the mating component. Punched holes. This is another critical factor. As you can see, what we are advising customers is to use and install our fasteners from the punch side, what we call from the punch side. This is down to and most of you who are working with a metal sheet I'm sure you will know about this phenomenon. So typically 1/3 of the panel thickness is controlled. So diameter, specified diameter D is controlled on pretty much 1/3 roughly of the thickness of the sheet. After that, it's a tear. So basically we are tearing material, and this is uncontrolled. It can be, I don't want to say controlled, but it can be somehow alleviated with tight control of the punching dies and punches. However, it cannot be eliminated completely. And what we are saying here, this diameter from the punch side is controlled. We know its diameter. From this side, it's uncontrolled. We won't be able to control this. And where possible, we advise our customer to have installed fastener into the punch side of the sheet. Again, it has to do with the material. It has to do with the material and the volume of the chassis and material that we need for undercut. If we have a bigger diameter, you can see there is increase in diameter. We wouldn't have enough volume to install successfully. Centerline to edge is another very important characteristic that we do publish. It's basically distance from the center of the hole to the edge. What could happen is the fastener, when we are installing, it's called as a hoop stress, where everything is moving towards the center of the hole. However, if we are too close to the edge, material, instead of flowing to the center, will flow outside of the panel. And this means that we wouldn't have material, as you can see, we wouldn't have material to flow into undercut. So there are several ways how to prevent it. One is to install, obvious one is to install within the centerline to edge distance. But if you have applications that is that we don't have any potential to change the design, we might look at the installation equipment that will support this edge and will kind of prevent material from bulging. But I advise, based on my experience, to review on the case-by-case basis and make sure that it works for your application, because it's not a cure for every solution. And other similar to proximity to the center line to the edge is the center line to the bend. And we need to we need to be sure that we have considered, or designer considered, all the potential issues with this type of the installations. One is the spacing of the fasteners. As you can see, if we are coming too close, we might not be able to install one of them. And then another one is it has to do with a similar phenomenon as we see for the centerline to edge distance, and it's not enough material. So we need to be careful as well with proximity to the bands. Again, we are not saying it's not doable, just there are special consideration need to be taken for that. Also, if possible, bending should be done before installation. Why we are saying that? If you imagine, if you have panel in the flat condition, and then we successfully install fastener, we are bending this panel over, and what is happening here is material with the bending is moving this material away from the undercut. So basically we will be, whatever we packed or pushed into the undercut area, which is holding the fastener, we are taking it away then. So again, just a special consideration for this type of the applications. Spacing multiple fasteners is a similar issue as a centerline to edge distance. So what we have, same rules apply as for the centerline to edge values. If we have several fasteners close to each other, we might see similar issue as installing fastener close to centerline to edge, and we might not have enough material. And again, use the same values as the centerline to edge distance. There are several ways how to tackle this type of the issues. We can try to look at the installation at the same time, so we wouldn't have material enough time to decide where you want to go or to pull, so we are doing everything on one stroke. But again, another consideration that needs to be taken when designing and installing fastener. How we can address centerline to edge distance issues is we have a design of the fasteners that have a custom design really to address this type of the issue. There is a trade-off, of course, because we are reducing the footprint of the installation and the self-clinch features. There is a slight reduction in the performance values. However, if customer has no other way than to install those fasteners close to edge, in most cases that we work with, it's sufficient. These type of the fasteners provide enough performance for this type of the application. And types of the fasteners, how we are addressing it is the DSO standoff. So instead of having a hex head fastener, we have round head fasteners, which due to its shape allows us to install it into the close to the edge holes, and knurled head provides the anti-torque feature, or is an anti-torque feature. And then we have FHL and SMP nuts. So these are pretty much, in principle, standard parts with a reduced clinch profile. As you can see, head diameter is slightly smaller, and the clinch profile for the SMP nuts are smaller as well, to make sure that we are not moving as much material and addressing those issues. Another big one is impact installation. Clinch fastener cannot be installed with an impact blow, and we have a big hammer. It's a bit of exaggeration, but trust me, I did see throughout my years in PEM that some customers did install it with the hammers. The reason for it is we need to allow fastener material to cold flow. So we need to have certain what we call dwell time. Even if it's a minimum, it still needs to have this time to cold flow. With the impact hammer or any other impact delivering device, we won't be able to create that time, dwell time, and it will not have time to cold flow. And then we can either destroy the part, we can damage the workpiece, reduce the performance, or you name it, whatever issue is there, you can impact this with this type of the installation. So where possible, use device that allows certain dwell time, not hammer, please. In terms of the material and finish, there are several consideration not to install fastener after paint or powder coating. The reason for that is either of the processes, paint and powder coating, is very heavy. It's very thick type of the finish. If we are installing fastener into the panel or chassis that is powder coated or painted, we can run into issues that the hole will be reduced because of the size of the paint if designer allowed for it. So hole diameter is right size after painting. We wouldn't have enough hard material, enough panel, enough steel to move into the undercut, and literally will be moving paint, and paint or powder coating will be holding the fastener in the sheet, which I believe you agree with me is not ideal. Anodizing complete aluminum assemblies may cause slight color differences. Again, this is based on experience. If you have any application where you need to have aesthetics, where aesthetics are important, anodizing process will cause discoloration of the fastener. So it's not so much issue with the fasteners, even though if you are too aggressive in anodizing, you can eat some of the aluminum from the self-clinch, but typically main issue is the color differences between the fastener and the panel. So I would pay attention to it if you have any aesthetic requirements for your application. When using steel panels, install plated fasteners after panel is plated. I believe that's self-explanatory. If you are using steel panels, fastener needs to be plated prior. Do not plate the entire assembly. There are few reasons why for it. One of them is the thread size. For example, we would need to accommodate then our thread size would need to be special. So we do recommend plate the assembly or install plated fastener into the steel panels. Beware of processes such as hard coat anodizing and nitridizing them by increased panel hardness. Again, this is going into the panel hardness requirements to install successfully fastener. Proper alloy. This means that we have dedicated range, and this is aimed for the stainless steel fasteners and stainless steel panels. I know that logically, based on experience, you would use 300 series stainless steel panel in 300 series stainless steel manufactured fasteners. That's not the case for our fasteners. If you go back to what we discussed, that the panel needs to be harder than, fastener needs to be harder than panel. Our 300 series stainless steel fasteners are not heat treated, so we will not have successful installation. However, we have dedicated range of the fasteners that addresses this issue, which is either 400 series stainless steel fastener, or if you need corrosion resistance, we can go for 8-86 precipitation hardened fasteners. And slow laser cutting operation may locally harden your hole. If you are working with the lasers, typically they are cooled by the water. And if we are going too slow, you can harden the hole around or area around the hole. And again, this might present an issue for successful installation. Any questions so far, guys, from anybody? No, okay. I'll keep going. Again, if you have any questions, either use the chat or we will have a section at the end of the session, and we can go through your questions later on. In terms of the performance testing, how we are testing our fasteners is push out test, where we are testing really fasteners and its resisting, how well it's retained in the panel. So we will apply the axial force, how much force it will take to push out the fasteners out of the sheet once it's installed. Here you have typical depiction of our fastener and of our testing, how we do testing in condition, and how we do recommend as well customers test the fasteners. Very recently, 2 weeks ago, I had a customer who was testing them with a hammer, and he told me they're failing. So I wasn't sure how they install it. They were just saying that they're failing and they're falling off the sheet. We did all the testing for them, and at the end of when we submitted the report, they see our testing specification, and they said that that's not how they tested, that they tested with the hammer. So that's something we strongly recommend not to do, tested with the hammer. And there are a few reasons for it. You don't know the force you're applying, it's an impact force, and you can't control it really, and several issues with that. So please use either some sort of the device that you have, some tensile testers, whatever device you have to test, or leave it to us. We do not hesitate to support you with the testing to make sure that our fasteners are used correctly and they perform as specified. For each product, standard product, we have specification in terms of the performance testing. So you can find this information on our bulletin. These are the values that we stand over, that we can guarantee. And if fastener is not meeting this specification, we will investigate what the issue is, whether it's an issue on our side in terms of the fastener, or there's an issue with application of any of the reasons that we discussed previously. So going through the testing, really, it's quite simple. We have fastener installed into chassis in the panel. We have the bushing, hardened bushing with specified diameter. And then we are applying load or force through the mating screw with specified hardness, and we record our values that it takes to push the fastener out. Important thing is we need to push opposite of the installation direction. We cannot push from this side purely because we will get additional support from the panel, and it will generate false reading. Torque out is real, and there is, I just want to spend some time on this one. Torque out is the resistance of the displacer to applied torque. It has nothing to do with the assembly torque, which always is a question from our customers. The reason for this, why we are testing, is this is the characteristic that we can test our fasteners for. This is the purely characteristic dependent on the design and installation of the self-clinch fasteners. So there is no actual torque. We don't apply any value or any load on the X. It's purely just a torque to spin the fasteners. How much momentum it takes, or how big momentum it takes to start fastener to rotate. There are two potential failure modes. One is failure of the panel, which is typically happening for the soft sheets. So fastener will be deformed before panel will be deformed before fastener. The other failure mode is fastener, where one of the features is collapsing under the load. Again, these are expected values, so we have the minimum values published that will that we can guarantee that our fastener will withstand. This is the depiction of typical application or typical test configuration. So fastener is installed into the sheet, into the sheet. Then we have the washer. The washer there is purely to accommodate for any potential unthreaded portion of the test screw, and then through driver or any other feature that we have, we apply the torque via torque wrenches. What I mentioned about the pure torque, this is the feature of the fastener. Assembly torque or tightening torque, it's more complex because there are components in the play that we, as a pen engineering, as a manufacturer, we do not have control over. This means that there are mating screws, mating components, mating panels, holes in the mating panels, tolerances, coefficient of frictions. So it's far more complex in terms of the tightening torque, and these values we cannot control. We are not in control of customer processes. We are not in control of the screws, mating screws that we do not supply, and hence we recommend customers to test our fasteners with the tightening torque. We have certain recommendation, but please bear in mind these are just recommendations. Another testing that we can provide, and I already touched that, is the finite element analysis. So really it's for the specific fastener and the panel material. It's a simulation based on this type of the testing. Typically, we are doing this for new products where we have new design, where we have custom design. The reason behind is for the all standard fasteners, we have enough historical data, we have enough testing, we have enough production data performed in the past, not to need this type of the application. Of course, it can be done. There is no issue to do it with the standard parts, but it's very rare that we do need to do it. For the custom, it's slightly different situation where we are evaluating panel material of the application and proposed values of the fastener in terms of the hardness, material, and so on. And it gives us failure mode analyzed, so we see how it's failing, what is failing, and when is expected to fail. And at the early stage of the design, we can optimize it and do minor tweaks to be able to address any potential issues. Okay, guys, if that's okay with you, I propose 5 minutes break. Just to.
Yes, sure, Stan.
Not to put you asleep, everybody. So yeah, if you are okay, guys, with it, I will reconnect in 5 minutes, 10 or 15.
Okay.
Okay. Excellent, guys. Okay, guys, I'm back.
Okay.
All right, guys, let's continue on. Any questions so far on presentations? All good? All clear? Great. Okay, let's continue on the application review and a few examples where to use our fasteners and how we work. So in terms of the stats that we did review, stat is one of three our biggest groups that we are supplying in terms of the applications. So we have, as you can see on this slide, we have several types of the stats. These are to address different or specific requirements that the customer might have and that we felt the need to have as a standard. The most common, or one of the most common types, is the flush head stud, which is very straightforward fastener that can be installed into aluminium, can be installed into cold rolled steel with the appropriate installation copper as well with the consideration. And then we have FH4 FHPs, which is the same type of the stud, but targeted to be installed into 300 series stainless steel panels. So these are for the applications where customer needs to have flush surface after installation for some level of aesthetic requirements from the customers. Then we have FHLs or FHLSs. So these are for the applications close to the center line to edge, what we've discussed previously. TFHs are for the very thin sheet panels. So as you can see, 0.5 millimeters. That's quite thin panel that we can install into. HFH are heavy duty studs to provide additional support in terms of the actual tightening torque. HFHBs are similar but manufactured from bronze, and these are for the heavy duty bus bar applications for automotive industry predominantly. HFE are heavy duty studs again, but to control the maximum pull through and to make sure that the fastener will fail in the stud, and so on and so on. So you can see that we have several different styles and several different types of the studs to address different types of the applications that customers might have. Last but not least are the FH pins or TP pins. These are unthreaded what we call studs or pins installed into the chassis where are used for the location purposes. Here is a installation of the stud and how it works. So stud, if we are presenting it to the panel, preparation of the installation equipment, and then Rafael, is it you with the laser pointer? Okay, I'm sure. Okay, so this is the how it works and what we are doing with installation of the stud, applying the force as we discussed on the explanation. Material does all the work, so we are just pushing fastener into it, and in the blue area, panel is flowing into the desired areas, and we have successfully installed fastener. In terms of the tooling, you can see that installation tooling is designed to suit this type of the fastener. So each type of the fastener has its own unique type of the tools. There are several applications or there are countless applications where you can use our studs, and we've picked just a few of them to give you the flavor where they can be used. So this one is for the electronic scale, and what we have here is the stud we installed into the panel. And as you can see from the other side, customer has a requirement to be flush or to be flat after installation. So from this side, what you can see are our studs installed into this chassis. And from the other side, it allowed, because of the flush installation, it allowed customer to put protective or whatever he needed to place there, the plastic with the numbers, with the buttons to navigate throughout the selection and throughout the menu. So using the flat flush studs, allowed us to address customer requirement for cosmetically pleasing finish. And this type of the product was installed together with the standoffs, as you can see, and touchpad was completed afterwards by the customers, and we were able to meet customers' requirements. Another type of the applications is automotive. This is for the torque converter rings, where we applied and used HFH stud. In this particular case, it was HFH M10 thread with special pitch, 1 millimeter. And this is used in the, as I mentioned, torque converter for automotive transmission. What we did with the customer in this particular application is customer came to us with the application if we can streamline and reduce cost for his application. So we did series of testing. At the time, customer used 8 weld studs. So we did a lot of testing with our studs for this particular customer, and we were able to replace 8 weld studs and nuts using 4 PEM studs. So we reduced number of required components by half. We were able to reduce his overall cost for installation process as well, or process that he used, which was welding. And basically we accelerated his lead time, and this yielded into 50% cost advantage over entire project for the customer. As you can see, saving customer 50% on cost of something is very significant, and a lot of purchasing guys love that. So it's really win-win for everybody. It was good for us to be able to show advantages of using self-clinch. For customer, it was win. Certainly, if we use reducing cost by 50%, and also another bonus that is listed there is that the customer discovered that using the self-clinch stud and installation process recommended by us almost eliminated the need for fine and balancing of the ring assembly. So after welding process, customer had to balance this assembly to make sure that everything is in the right position. By using technology of self-clinch and using following our recommendation, customer was able to eliminate this one. So overall yield, overall cost advantage was even higher because we reduced some quality costs for them as well. This is another application for industrial market segment where we used our FHL, which are centerline to edge or closed centerline to edge solution for electric scale. And customer required fastener that could be installed into very small footprint. If you can see picture here, it's very, very narrow space we have. Our standard FH certainly wouldn't be able to install that in the way that our FHL fastener is capable of, purely because of the cosmetic requirements. We would see some bulging here and on this side, and footprint as well. Installation access would be problematic as well. By using FHL product, customer was happy with the performance. Customer accepted a slight reduction. However, it was way over whatever he required. And we were able to install and clinch this fastener as close as 5.6 millimeter from the center line to edge, which is pretty phenomenal if you're talking about the M5 stud. So if you have, or if you come across any challenging applications where you have difficulty to install or to apply thread internal, external, and or spacer, let us know. We can look into it, and I believe we can address those as well with our technical team. Other big group of the fasteners and few example of the application is the S-nuts. Again, we have several different types of the S-nuts. Same logic as for the studs is to address different materials, different challenges that are there or out on the market. The the biggest group is the S-nuts, standard S-nuts. We are talking about the S-nuts, CLS. CLS is manufactured from carbon steel, stainless steel, and aluminium. These provide long load-bearing threads in thin sheets with high push-out and torque-out values that we've discussed previously. So really, if customer requires reliable thread, hardened thread in his thin sheet application, S-nut is excellent solution, excellent choice for them. SP nuts, this is our response to challenges to install into 300 series stainless steel, similar as we have for the FP and F4 style fasteners. RT is relatively new. It's a special locking nut, which is locking when clamp load is applied. What it is, typically market has a solution for clamp load. Not sure what happened there. Yeah, for clamp load is using adhesive nylon rings, any other components that would have the locking feature. With this type of the nut, we and our engineers designed and developed special shape of the thread called rump thread. That's why RT is coming from, and this will allow fastener or joint to be locked once the joint is in the tension. So once we will apply the mating components, it will lock itself, and we have very nice feature there, vibration and vibration resistant feature. So this, again, without any additional elements, we can provide this with the RT, the free running lock nuts. More traditional way how to address locking is applying the trident, what we call a trident. So basically, it's mechanically deforming first thread at the entrance, and this will provide the locking feature on the 3-cycle locking performance requirements, which are industry standards. And then we have H and L, non-locking and locking studs, high push-out and torque-out resistance. I'm not sure why this one is still keep moving. Sorry. And SH are fasteners from carbon steel for hard panel nuts. This has been developed for automotive industry predominantly. This is what did drive development of this type of the fasteners, where our customers are using very high hardness chassis alloys that required specific and special type of fastener, and this is PEM engineering response to this demand. Last but not least are SMPs and SMPPs. These are fasteners for thinner sheets and close to centerline to edge application discussed. Design intent, you already seen that on our previous slides, but repetition is the mother of the wisdom. So we will again see how blue area of the panel will cold flow and retain fastener. We will apply mating components and joint is complete. Several applications how and where you can find our nuts, but again, it's countless solutions where we offered throughout the industries, and this is just a few of them. So this particular one is for automotive industry, for the armrest, where we installed our fasteners. As you can see, this is the shape of the bracket which supports the armrest, and we have several fasteners. We have several fasteners to fix the position. Self-clinch was selected over the welding, where we provided solution over competing technology. Welding for the aesthetic reasons, for the accuracy, for the convenience. It's much more convenient to install those fasteners by using installation process recommended by us. F nuts, these are specific type of the S nuts. There are still nuts internal sheet and provide flush installation. So these are ideal for wherever we are competing or customer has demand for strong thread or heat-treated thread or hardened thread against typically used tapped hole. This is where we would recommend and select this type of the fastener. It's very aesthetically pleasing solution. We have several applications where our customer had a demand and it has to be flush, and we were able to address this one with this type of the fastener. Principle of the installation is the same as any other S-nuts or standoffs. Here are some examples where we can use. This particular one is for food service and for the display case with the sliding door, and for the wheel assembly, as you can see here, for this particular one that is placed over here. So for this particular application, customer requested or had demand for M5 F nuts, and we were able to provide. As you can imagine, if customer just tapped the hole into this one, the thread wouldn't be as strong as using one of our fasteners that are heat-treated. And this allowed wheel assembly to be flush, so it can slide freely in the door frame. And due to the space and the restrictions that we had, that was ideal solution for the customer. Other type of the fasteners that we can provide are miniature fasteners. These are not in the category of the PEM micro, but these are what we call miniature. So they are typically smaller than standard style fasteners. And we do have locking and non-locking version. Again, depends if customer has any requirement for prevailing torque, lock nuts, or mating hardware from loosening, etc. If there is any requirement for that, we would select or recommend customer either locking or non-locking. And these are fasteners predominantly used in the minimal space where customer has restrictions in terms of how much space he has available to install the fastener. So we would select one of those. Again, it's just a variation of the S-nut. Self-clinch principle is the same, but it's just to give you an idea that we are not only limited to the fasteners that we presented before, but our portfolio for the standard parts is over 7,000 different part numbers. For the special, it's around 4,000 and above. So in our portfolio, we have over 11,000 different styles of the fasteners. And I believe from those 11,000, you can find solution for most of the customers. If don't, we can always look into specials. And these are just an example where we used the FO locking nuts or miniature lock nuts. And again, customer, as you can see, panel here is relatively small. We do not have much space there. Using conventional S-nuts would take even more space that current FO solution did. So we were able to provide this type of the solution. And again, we helped customer to reduce the loose hardware, provide a locking feature. Customer, which was hardened, customer didn't need to have a tapped hole, which was unreliable thread. So overall, it was win-win for both companies, for us and the customer, where we were able to match the right fit for his requirements and for his application. Another big group of our fasteners, what we already mentioned, is our standoffs. Again, selection of the fasteners, not as rich as on the previous types. However, we are addressing customers' demand and needs. Don't want to spend too much time on it. And I also want to comment, do not be scared of all abbreviation, SO, TSOs, S-nuts, and so on. if you have any applications, let us know what you're looking for, brief description, and then we will try to identify the part numbers. It's I know it's yeah, for me it comes naturally, but it's you know, don't be scared by it. It's a different type of application, and we will guide you through it entire process. Or Dominic and his team, I'm sure they are happy to provide support for this type of the requests. So as you can see here, we have two types of the studs, of the standoffs, excuse me. One is through threaded or through hole, and one is blind. This selection is purely on the customer and his requirement and demands. If customer has any need to be sealed from one side, then when he selects blind threads. If customer has a spacer that he needs to use longer screws in mating components, there are several aspects coming into consideration. We would select through hole, or customer would select through hole, and then we have fastener for the thin sheet, which are TSOs. Again, not going through it in too much detail, but there are several different types to address different issues with the customer. Design intent of the installation. The principle is the same, as I said, across the board. Really, applying the force, material will flow, and as you can see in the blue area, in the blue area panel will do all the work by applying the squeezing force, and we can apply mating components. Okay, and some application example where we used, or customers are using our standoffs. In this case, it's aluminum SOA, and it's a treadmill motor for the control board. So on each treadmill, treadmill knows how hard he needs to give you the training. You need to have a control board, and this is where our fasteners are used. Original design from customer was a combination of the plastic snapping fasteners and loose hex spacers. So this type of the process required hand assembly, and customer selected, or we selected together with the customer, SOA M4, or one of our standoffs, and this simplified and purified the design and reduced the labor cost excuse me, necessary to attach the entire process, to attach the heatsink to the chassis. So we simplified the entire process for the customer, and this is something that the customer values a lot, where they are able to see where they save some space on the boards, where we are able to save them on the labor-intensive operations, and make sure that our designs are meeting their demands. So this is something, again, just a few examples, one of the examples how we are able to help customers to get better applications. This is quite unusual. It's and it just shows wide range of the applications where fastener can be used. It's a mailbox front panel, so everyday use. It's a mailbox where we are picking our post letters and mail, hopefully good one, no bills. And initially customer were using stud weld, and that was the method that he used. But position accuracy was a big issue for the customer, because not all the panels were, or holes or thread positions were in the right places. And perpendicularity was another issue that customer was facing. So we were able to replace blind standoff, or replace weld components with the blind standoff. We put it in as you can see on the pictures, it's very aesthetically pleasing. You don't see any issues there. Panel after paint is nice and flat. You don't see any marks of our parts. And we use the same material, so aluminum and aluminum, which gives us big advantage for the customer. And basically everything worked out well for the customer, and result is excellent in my opinion. And our fasteners were able to meet everything that customer needed from our side and for fastener. Just one point that I would like to highlight is that PEM engineering, and I mentioned it at the beginning, is not only commodity supplier. We can walk through the entire process from design to mass production, and we can work with each members of your team from purchasing through engineering, through production, design, you name it. We have dedicated teams that can connect with appropriate teams, and through our distribution partners, we are able to communicate, and we do provide solutions for all of them. So it's starting with application and design expertise. So first of all, we are selecting correct fasteners for the given application based on the information we've got from the customer. For certain applications, and sometimes I know from my own experience, we do ask a lot of questions. I know occasionally customers see it as getting information from them that's annoying, that we asking all the questions where he just wants simple fastener. Trust me, it's not to pull any information from you. It's not to be annoying. It's to make sure whatever we design works for you and for your application. The more details you give us about the panel material, about the application where you want to install it, how it's intended to work, better solution we can offer. If you can give us this information up front, better for us. We are able to make an educated decision what we are going to offer to you. And it goes from specials through standards as well, because there are instances where customers selected incorrect standard fasteners just purely based on the lack of information or lack of due diligence done on either customer side or fabricator side. It's not to put the blame, really, it's just to make sure that we are supporting our customers with design. So if you have any questions, if you have any applications you would like to review more, you give us better solution we can offer to you. And of course, we are aware of confidentiality issues. If NDA needs to be assigned, if there is any issues that you cannot share information, we fully understand and respect that, and we will work with what we have. But again, the more information we have about the application itself, we can provide better solution. And this leads us to design FMEA optimization. So we, based on our product selection, we can optimize the entire process. As you could see on the several application examples that we had, we are able to improve process and design of the fastener application. We can improve, and there are, in certain instances, there are effects that we didn't even anticipate at the beginning, but it adds another benefits to the customer, such a clean or environmentally friendly process as position and accuracy, and all the other benefits that comes with the using self-clinching. This comes in hand with the installation expertise and recommendation. PEM Engineering owns the PEMSerter brand, which is the in-die solution, and PEMSerter Series 4, and Hager installation presses. So we know how to install our fasteners, and we can make appropriate recommendation for you in order to installation. We have installation experts in each of the locations, manufacturing locations in Europe, Asia, and the States. And also we are helping customers with the assembly solutions, whether we are talking about fully manual installation to highly automated assembly solutions. So really, we are not only commodity supplier, but also full solution supplier. This brings me to conclusion of my presentation. And if you have any questions, please let me know. Do not hesitate.
Anybody? Okay. Thank you, Stan.
Perfect. Guys,
no questions.
Appreciate your time and patience and attention.
Yep. Okay, so thank you for today. Like Stan said, if any question, you can reach out to me, to Stan, to Rafał, and we are more than happy to help you. So yeah, once again, Stan, thank you very much for your time, for your presentation. It was really good, and yeah, we can have an overview of the applications and PEM engineering in total. So it was really great.
Excellent,
Okay,
guys. It was a pleasure.
Yep. Thank you all for attendance. Thanks. Have a nice day.
Thank you, guys. Take care.
Bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
All the best. Bye-bye.